Hi, can you all hear me? Hi, can you all hear me? I think you all can hear me, but there's a delay, about 5 to 6 seconds. So today I'll give this introduction to the algorithm and analysis of algorithm through this channel. I think second half I will through this channel to give my lecture. So after the lecture, the video will automatically put in the playlist, so you should be able to find all the video. I also keep the last year the video, but every time I teach different part. So yeah, you and every time I give my it's a live streaming, so every time will be slightly different. And I already upload the notes. So sometimes if I miss out anything, yeah, you can refer the lecture notes also. Whatever I want to set is available in the notes. So you can refer the notes and the slide. I will upload more in the coming week, this week or during the recess week. Yeah, so what I will do today is I will give the lecture. So if you have any question, you can post it in the chat, but I may not be able to answer you immediately because there's a delay about 5 to 6 seconds, I guess. Yeah, based on my observation now. Yeah, it should be 5 to 6 seconds. So I think I will, in the end of the lecture, I trying to answer your question. You post it in the chat. I think that will be easier for me. Okay, so let us start the lecture. So this is my name, my email address, my office. So if you have any question, you can drop me an email. So first I will give the lecture for the about the algorithm. Next week you have the lab test. Okay, take notes. So my part, this week I will cover the analysis of algorithm. This week the tutorial is still about the binary tree and binary search tree provided by Dr. Owen, and lab 4. In the lab 4, and then the assignment deadline. I think he may change the deadline. You just double check with his email. For my part, I will in the second half. Today, this week one is the analysis of algorithm. So this part, there's no any coding. It's analysis the algorithm. You will find that it's the mathematics. I will show you later. Then for the second half of this module is about the hash table and the graph problem. So you have when you learn the linked list, you have learned the linear search. And when you learn the binary search tree, you learn about the binary search. And we will introduce another kind of a searching algorithm, which is using the hash table. And then we follow by cover one of the very important concept in computer science, in programming, in algorithm, which is the graph problem. It's a very big topic. In mathematics, in computer science, graph is always a very important problem you need to learn. So we will cover something, breadth first search, depth first search, algorithm, backtracking, and how to find out all the permutation and dynamic programming and a matching problem in the second half. The order I may change a little bit, depend the progress. Then the tutorial I adjust a little bit. So week 8, 10, and 12, we're going to have the tutorial. Then the lab will start from week 9 onward. And then in week 12, there is I think one is Good Friday, if I'm not wrong. So Friday group, there's a makeup on the week 13. The rest will be conducted in week 12. Then same thing, the assignment, I have 3 assignments for my part. Based on the time I release the question, I will give you 2 weeks to solve it. And I have to remind you that there's a plagiarism check. So if you get caught, straight away is get 0 marks for your assignment. So please take notes. Don't copy your friend's answer straight away, and you also won't learn anything. Then there's in the end of this module, in week 14, which is 20 April, we will conduct another lab test too, together with a quiz. It's all in one. You can consider it's one test. Just like in this particular test, there's a MCQ and programming together. So the MCQ part will test you the concept. Of from week 1 to week 13. Everything will cover, especially to this week topic, analysis of algorithm. As I said, analysis of algorithm, I won't be able to set any programming question for that kind of a problem. So it definitely will appear in the quiz. Then for concept in all the topic, linked list, stack, binary tree, to hash table, to graph, to all kind of dynamic programming, permutation, matching problem, the concept will test in the quiz. Then the lab test 2, so-called the lab test 2, there are 3 programming questions. Yeah, so again, it's 2-hour test. The format of the programming part will be similar to the coming lab test 1. Okay, so same thing. The first half is teaching you how to select appropriate data structure. And the second part is more on how do you design, what kind of a strategy you can use in the algorithm to design an algorithm to solve the problem. And also the second part, especially this week, is also will cover how to conduct the complexity analysis of an algorithm. So take notes that assignment wise, again, I think Dr. Owen have been talked about it, is 40%, which means that his part, 3 assignment is 20%. My part is another 20%. For the lab test, the coming next week one is 20%. Then in week 14 is 20% plus the final quiz, another 20%. In other words, week 14 is 40%. So so-called attendance of the test is compulsory, means that if you fail, you get 0 marks in that 40%, unlikely you can pass this module if you're not attending. Okay, so again, a lot of people keep asking, the lab is not graded, but if you choose not to attend the lab, you have to bear in mind the consequences that you won't be able to do well in the lab test. That is your choice. But yeah, so that's why I think the lab school policies, we will still take down the attendance, but it's not graded. So whether you want to attend it or not, choice is on your hand. Yeah, but I strongly recommend you to attend the lab, is because especially the second half onward, the tutorial, I will not talk about any programming question in the tutorial. As I said, for those who attend my tutorial section, you should know that the tutorial, I focus on the concept. Tutorial and the lecture, I will more focus on the concept. Same thing, you will find that the lecture notes of my part, I won't give any code. So you need to learn how to realize, after you understand the concept, you need to practice in the lab or at home or in the lab section to practice an assignment, to practice your programming skill, to realize all the concept you learn in the lecture. And that programming skill only through the practice. No matter how I teach you all the possible technique you can learn in the lecture, if you don't practice it, you still won't learn anything. Okay, so that is the things I would like to highlight. So this module, if you know your course structure, I have to highlight to you is why it's important in your curriculum, is because if you fail this guy, you have quite a number of courses you cannot take. Yeah, because it's the prerequisites of 201. So this module, we why we need to teach the analysis of algorithm is because later your next level you will learn the algorithm design and analysis. This particular module will teach you more about how to analyze the algorithm. So I would say my part is more on this week is just an introduction to give you some idea. Algorithm may not be something you touch. It's not really implement a program only. Yeah, there are some other concept in theory you need to understand. Yeah, and for you to prepare for the next level. And yeah, and another operating system also there's a prerequisite. So that is the important why. And you can see that our program have two, you can see there's a two part. So this portion is more on the theory. Another part, OODP, software engineering, is more on teach you how to develop a bigger program. Currently in the 103 and 107, what you have learned is more like a small program, I would say. And most I ask you to write like 40-50 lines code. So normally you may not see you need to sort it out in proper way the modularization or and so forth. Like what, but when you write a bigger program in 10,000 line of code, you can't just use this kind of a way to write the code. You have to design the software. So that's why there's another part is like more software development in 2002 and 2006, which will teach you the OODP and the software engineering. And this part is more on the theory part, is the concept and how you design the algorithm, how you analyze the algorithm, how do you know which algorithm is a better algorithm. Yeah, you should choose. You will learn in 107 and 201. So that's why the 107 is the prerequisites of 201. In 201 onward, you expect that we wouldn't ask you, we expect you already very good in coding. We wouldn't spend so much time to ask you to do all this assignment. Straight away, we only tell you the algorithm, and they wouldn't ask you to assume that you are able. So in the lab, or I believe that they wouldn't ask you to implement all the algorithm. In this module, I will focus on realize the algorithm, but I will not concern so much about whether the algorithm, the solution you have is efficient, is the most efficient or not. As long as you're able to solve the problem somehow reasonable efficient, that's mean under the limited resource you have given to you, you're able to solve the problem. I don't really care is the most efficient solution or not. As long as you get all the test case correct, I will give you the marks straight away. But you expect that in the next level, they expect you know how to select the most efficient algorithm. The more concern is whether you know which algorithm is the most efficient one. But here I tend to focus on whether you know how to implement and realize the algorithm and solve the problem first. Yeah, before we talk about how to select the best solution. So okay, this one I think we have go through the lecture, it's concept. So tutorial, I will focus on the concept discussion, and also to give you a chance to ask the tutor, to clarify some doubt. Maybe you encounter in the lab you didn't get the answer you want. There's another person bi-weekly to meet up and clarify your doubt. If you still cannot get the certified answer, you can drop me an email. Okay, lab test and quiz and assignment, all this is assess whether you really learn those things or not. So in the first part, we cover the concept. Important is like the pointer. You find that the pointer is the most important one in C programming, and then followed by the linked list, stack, queue, and tree, all this kind of a data structure. So at my part, I assume that you already know how to select the data structure. I wouldn't tell you that you should use this data structure or that data structure. I will provide the template also, but yeah, I assume that you already know all this data structure at my stage, my point. So, and we also will cover the second half is like the analysis of algorithm. So I will spend some time in each topic to talk about the time complexity, the space complexity, which will cover what are they this week, and then introduce some algorithm and what is the strategy they are using. So all these things again still cover in C programming. So again, before I start my topic, I need to let you know what is the algorithm. What is algorithm? A lot of people may have a wrong idea about what is an algorithm. So if you go and search, again, you Google search or ask the ChatGPT, they will tell you that actually algorithm, if you search Wikipedia, they will tell you actually it's before we have the computer, actually people already come out the algorithm. It's not really a programming or coding or something. It's a kind of a set of a rule, a process to do solving with a proper defined, well defined to solve certain problem, to solve some problem. And it becomes so popular after 1950 something is because someone invented a computer, and computer is very good in repeatedly do certain systematic process, well-defined process or operation. They do much better than human being. They can keep repeatedly do the addition, subtraction, all the logic very well. So that's why people come out a lot of algorithm and start using, and they're able to realize it. Before that, we don't have computer. It's a set of a procedure to tell people that if you want to find the greatest common divisor, okay, the first step is this, the second step is this, the third step is this. Then people just follow this step, they will be able to find out the answer. So that is the algorithm. So if you read all the textbook here and there, their definition, like in the introduction to the design and analysis of algorithm by Anthony Levitin, they said it's like an algorithm is a sequence of unambiguous instruction for solving a problem, for obtaining a required output for any legitimate input in a finite amount of time. So you must be able to solve this problem in finite amount of times. And you give certain input, same thing, you give certain input, they will give you the output, and every time they will produce the same output, just like the comment. This is another well-known textbook in algorithm, Introduction to Algorithm by Comment. An algorithm is well-defined, so all the procedure must be well-defined, and there's no any ambiguous terms like very big, big enough, or good enough, this kind of a statement. Every step is well defined. You want to encube, you encube. You tell me encube an item. You don't tell me that encube some item. Some is how many? 1 or 2 or 3 or 4. Yeah, so you every step is well defined, is very clear and simple. So, and then you go through this procedure, and you will always, if you give me the same input, you will always produce the same output in finite amount of time. If the algorithm, here we don't discuss those algorithms can run infinity. Of course, some in the higher level, you will learn some algorithm is if you run more iteration, you will get better and better result. But eventually, you also will set a threshold to a level, then you will stop. So it's still in the finite time. So whatever is computer won't be able to run something infinite. You also don't have time to wait for infinite amount of time. Yeah. So that is an algorithm, the definition of an algorithm. So in short, algorithm, in this module, we consider 3 things. Correctness must be correct. Yeah, your output must be correct and consistent. That means I give you this input. If input is 1, this time you produce the answer, let's say is 5. Then next time I give you 1 again, you still need to produce me 5. There's no randomness. Here we don't discuss those stochastic process or random process problem. So the problem is always is a finite state machine kind of a problem that you can solve it in finite times and finite state. And then precision. That means is every step, every procedure is well defined, and the whole process are also well defined. Not sometimes you run this for loop, sometimes you may not need to run this for loop, and there's no any condition whether you should run or you should not run. It's a random. Those such thing in the algorithm in this algorithm module, everything must be well defined. The step is well defined. The whole procedure is systematic, and the step order, all these are well defined. And there's no maybe roughly about all this kind of term. Everything you are able, in short, it's like you are able to implement in a program, and they must be able to terminate in a finite number of instruction. That's why you won't run your program, your algorithm cannot take infinity time to execute. So finiteness, precision, and correctness. So that is the three components we considered in an algorithm. Okay, so what is the difference between algorithm and the program? And usually they are not the same thing. Okay, generally speaking, they are not actually the same thing. Is when I have a problem, actually the first is you understand the problem, and then the next step is after you understand what is the problem, and then you trying to sort it out, an algorithm, and which is the well-defined step procedure, and every step is well-defined, and then it's systematic to solve the problem. And then program, whether you implement in C, in C++, in Java, in Python, in whatever programming language to write a program, such that you can execute it and to take the input and produce the output. That is a program. It's just an instance of an algorithm in certain programming language. So it's trying to realize your algorithm. You write a program. So they are not actually the same thing. A lot of time we touch that they are actually the same thing, but not true. Algorithm is just a procedure. It's just and you can think it's just an idea to solve the problem. You may not need to really go and solve this, implement it, but you need to come out the algorithm, and then the software developer, the programmer, will use your algorithm to solve the problem, and by implement it as a program, and they write the code. So you will find that a lot of algorithm textbook, there's no code, and all of these people are mathematicians actually. They just tell you the procedure to solve the problem. They don't tell you how to implement it. So you will find that when you go to higher level, a lot of time it's harder to know how to implement it, because they only give you the idea. That's why in this module, I would like you to train you is I give you some algorithm. You need to be able to realize it into a program, because when you go to higher level, those algorithm is even harder to implement. If you don't practice today, in the future, you're unlikely able to realize those algorithms. So just some simple example for you. Maybe I want to count, like to sum up some number from 1 to n. N can be any positive integer number. So that means if n equal to 100, that means I want to sum 1 plus 2 plus 3 plus 4 plus 5 to 100. So how to solve this problem? I think very straightforward way is like I just simply write a for loop, then let I equal to 1, and then every iteration I just increase by 1 by 1 by 1, and then keep sum. I have a sum. I have a variable sum. Initially I let it become 0. Then I run an iteration, a for loop, iteratively fit 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 into sum. Then at the end of the for loop, I get the answer. Well, that is one solution. So, but for those who learned the series before, you should know that this is a kind of a arithmetic series. So if you know the formula, one line code. Yeah. So it's like you're trying to summing up 1 to n. That's when you got n item. So it's n over 2. The first one is 1. The last one is n. So the formula is n over 2 times 1 plus n. Then you get the answer instantly. Yeah, of course, you also can, some people said they know recursive function, they can write it recursively. That means you can start from n, then recursively call the same function, then keep adding n minus 1, n minus 2, n minus 3, n minus 4, 5, 6, 5 to 3 plus 2 plus until you reach the base, which is n equal to 1, then you return 1. So all this is the solution. But yeah, here among these, what do you think? Which one is more efficient? What language will we use? Again, it's still in C programming. Yeah. So what do you think among these three example, these three algorithms, which one will give you the best, more efficient one? Yes, I think someone answer is 2. Maybe I need to wait for a while. Okay. So correct, because you can see that it's only one line. And to find out the answer, I just need to do the multiplication and one addition and one division and then one assignment. It's whatever you give me, whatever, and I always do the same procedure. I can find out the answer instantly. But if you the other two, the n is growing bigger and bigger and bigger, then my for loop need to run more iteration, or my recursive function, I need to have a more and more and more recursive call. So that is the problem we need to discuss in this week about the analysis of algorithm. How do you know this algorithm is good or that algorithm is not that good? Yeah, how do you define good or bad algorithm? Yeah, we will discuss in this week. Maybe I can give you another example, which is a well-known algorithm, which is called a well-known sequence, Fibonacci sequence. You may learn before. Initially is 1, 1. Then the next number is the sum of the previous two, 1 plus 1, so it's 2. The next one is the previous sum of the previous two term, which is 1 plus 2, which is 3. Then 2 plus 3, you get 5. 3 plus 5, you get 8. Then the next number will be 5 plus 8, you get 13. Then 13 plus 8, you get 21, and so on and so forth. So that is the Fibonacci sequence. And the problem is I want to find the n term. What is the number? The n term, what's the number? So again, if you know the definition, where the most intuitive algorithm you would like to implement will be this one, a recursive function. Yeah. So that means you want to know the n, which is you recursively call the n minus 1 and n minus 2. And then you keep repeatedly do this recursive call, then you eventually reach the n equal to 1 or n equal to 2. You know that the answer, the first two term is given. The first two term is 1. So you just return 1. Then you will find, and then you start return, and then sum it up. Then you will find out the answer. So this is the recursive version. Of course, I can implement the iterative way. But what do you think again? This algorithm 4 and algorithm 5, which one is more efficient? Four. 4 is more efficient. Then it's not correct lah. If you think 4, then not correct already. If you look at 4, actually it's not really the most efficient one. If you look at it, I give you an example. If today I have an algo, let's say my n, I just need n equal to 4. N equal to 4. I do this, actually n equal to 4. Okay, your n equal to 4, which means you need to do 2 recursive call, which is let n equal to 3. You will call recursive call n equal to 3 and n minus 2, which is n equal to 2. You have 2 recursive call. In each of the recursive call, you need to do another 2 recursive call, which is n equal to 2 and n equal to 1. Then this one will be another 1, 2. Okay, 2 will return already. 2, I will return. Yeah, based on my algorithm. So in that case, total number of recursive call you have done, the function call you have done here is 1, 2, 3, 4, 5. You did 5 times. And this is just, and you notice that here you do 2 times. If your n bigger, you will find that you repeatedly call the same given the same input and run the same call multiple times. The largest number, you will take more. Yeah, so in that one, this one actually, okay, is out of the scope of this module, but just for your information, the time complexity is 1 plus square root 5, 1.6 something power to n. Yeah, it's a function. The complexity is or sometimes people may say it's a 2 power to n. Yeah, it's an exponential. You will find that it's actually exponential. In fact, you can simply try to implement such an algorithm. Don't need a lot. N equal to 100. You will find that you are surprised that you will take you, even you have a very good computer, you also take you sometimes to get the answer compared to this iterative way. Because this one you got n, you just run n iteration. And moreover, actually this algorithm 5 is still not the best algorithm. There's another algorithm I will not discuss here, but you can go and find out which is can achieve in log n. Yeah, this one is in n. It will be in linear because you have n iteration, you just run n iteration. But there's another one. You will find that actually if you observe carefully, actually you still repeatedly do some calculation. Oh yeah, in the every iteration. So actually there's a more optimum way is in log n. Yeah. So that is like there are a lot of algorithms you can choose to solve a problem. But we need to analyze the solution and which one gives us the best most efficient way to solve it. Then we implement that one. So normally we don't brute force to try all, yeah, or just simply implement whatever things and then try it out and find not appropriate. When the problem getting more and more complicated, you will waste a lot of time to implement those inefficient algorithm and realize that it doesn't work well, and then you need to find another one. So sometimes people will analyze it and find out there's which one is the best one, then they implement that one. That is good enough. So actually in this question actually is algorithm 5. But actually there's another one. You can go and find out by your own, which can achieve in log n. Yeah, there's another better one. So there are, okay, back to just now earlier one algorithm. Actually, there are a lot of kind of problem. In this module, we discuss only the searching, the graph, and some combinatorial problem. That means the permutation, the combination problem. And in the next level, they will discuss sorting, the string processing, and some mathematics courses. They will teach you the geometric problem, numerical problem. I will briefly introduce in the next few slides. So searching, the most intuitive one you have learned in the linked list. In fact, I think anyone should know this is some common sense. You have a sequence of number and then you want it, but they are not stored in order. You want to search whether the key is inside the sequence or not. Then no other way. You have to check every single one by one. And such a search is a kind of a linear search. Yeah. So when you found it, you return. Yeah. Then every time, sometimes you're lucky, the first item is the one you search. Then you just need one step. But sometimes you may need to run through all of them. And the worst is that you find all of them, none of them is the key. Then you can't find the key. So So overall, you will find that this one is why you call linear. You will take linear times to search it. Then in week 8, I will cover another way to store the data. If you have a smart way to store the data in certain form, like hash table, every time before you store the data, you have a function, a unique function, a hash function to map it to certain index. Then next time you search that particular key, particular item, I just need to fit the same function and then go to that index. If the item is in that index, then you get the answer. If not, then there's no such thing. In such a case, you will find that in week 8, I will show you, you will find that you just need to take constant time, because every time you give me, I just fit the function and then go to that index. It's always the fixed same procedure, and in constant time, I can find out the answer. But of course, that one, there's some trade-off that implied you need more storage to store the data. So there's a pro and con, but yeah, in terms of time and space. Yeah. So application-wise, to search in daily life, a lot of problem, you always are searching the solution. Just like Sudoku, you may play before, you always are searching the horizontal and vertical and in the 3x3 grid to find which is in use, which one is not in use, then to find the possible solution. There's a part of it is a searching. Yeah. So that's a one of the searching problem you encounter. And another graph is another kind of a problem in the computer science or in mathematics also. It's a kind of a structure, consists of a collection of a vertex and edge. In the past 2 weeks, you learn about the binary search tree. You can consider that is also a kind of a special case of a graph. So yeah, then each edge has a 1 or 2 vertex associated to it. Each edge have a 1 or 2. Each edge have 1 or 2. Then yeah, so you can form a network. Then you can find you may trying to want to visit every node in the graph, or you want to search a path in the graph, or and so on and so forth. One of the application is like path finding. So you got the just like you use the Google, or Google Map. Yeah, Google Map behind actually they are trying to search provide your source and destination, then they're trying to calculate it's a network. That's your map is a network. They're trying to find the shorter path for you to travel from the source to your goal, to your destination. So that is a kind of a network problem, a graph problem. So it's also, or you can call this a well-known problem, traveler salesman problem. Yeah, they provide, you got 50 city and you want to visit all of them once, and you need to find the route, and eventually you need to go back to the first city you visit, and that there are a lot of possible solutions, but which one give you the best solution? And you will find that actually you don't have other choice. You have to try all the combination and find out the shorter path. That is a traveler salesman problem. That is a kind of a graph problem, a well-known graph problem in computer science. Yeah. Combinatorial problem is trying to solve the problem like arrangement, some pattern, or assignment, the duty, the job scheduling, and so on and so forth. Is a kind of a combinatorial problem. Actually, you're trying to find all the combination, and then among all the combination to find out the best solution or certain solution. One of the well-known application is in the cryptography. So in the cryptography, for example, I want to transmit a message, then I need to encode and decode. Of course, when I encode it into certain form before I transmit out, and decode must be decode in the same invertible. But I don't know which other people know the secret. So they have certain I need to ensure that not only people know won't be able to decode it easily. I also need to ensure that all the pattern have a unique solution. That's mean the other side, when they decode, they won't give different answer, different message. So that's mean the encoder and decoder, they need to try out all the, when they design the encoder and decoder, they need to ensure all the permutation, all the combination always give you the unique solution. So that is a very classic combinatorial problem. Other kind I will cover is the matching problem. It's very common in your daily life. For example, when you do your FYP, we propose some project, and then you need to select the project, and at the end, the system need to find the matching to match based on your preference to match and give you the assign you. That's a very typical or the job. It's a kind of a job assignment problem. So it's trying to assign that project to you. So that is but at the same time, maybe it's like in this example, like cutting, maybe it's a project. Tom and Harry would like to do the cutting job. At the same time, packaging, also Tom and Harry also would like to do the packaging. But eventually, we just need to assign one job to each worker. So in the end, it doesn't matter that I can simply let the packaging job assign to Tom, and then Harry get the cutting job, and then polishing will assign to Dick. So the problem is how to find an algorithm to assign a job to each person. And matching problem don't concern whether should select Tom or Harry for cutting. As long as I assign one job to one of them, that is good enough already. So that is a matching problem. It's a kind of a combinatorial problem. Of course, this is not the unique solution. You also can, I think you can find that I also can let cutting job assign to Tom, and packaging can assign to Harry. But that is not the problem we concern. We just need to concern is find a solution to assign cutting to Harry, Tom to do the packaging. That is good enough. So that's the one of the classic problem in combinatorial problem. Another one is the minimum vertex cover problem. Let's say you have a network, a graph, you want to find the minimum number of vertex, minimum number of nodes, which can cover, that means the adjacent nodes, all the adjacent nodes of these two red color nodes, actually already cover the whole network. Yeah. So what kind of application people want to do that? For example, the traffic police, they want to know where they need to put the checkpoint at the state, at which junction. They, of course, you got limited manpower, so they need to find the minimum junction check as a checkpoint to check the car at the midnight or something like that, or whatever reason they want to do. So they need to find, they can use this kind of a minimum vertex cover. It's a minimum vertex cover problem. Then they need to find the minimum number of checkpoint they need to allocate at particular junction, such that all the car have to pass through this junction, and then they can check all the car in this traffic network. So that is another kind of a problem. Yeah, in your daily life, we need to solve it. So another popular problem we are interested is sorting. As I said, searching, if you sort out the data in certain form, then your searching time will be shortened. Just like when you learn in binary search tree, the binary search tree already sort the data to put the smaller number at the left subtree and put the bigger number at the right subtree. In such a case, your search time will be shortened. And then, so sorting is another problem we are interested in computer science. For example, you want to find the median. If the data is not sorted in order, you have no choice. You need to find the median. You need to take some. You'll find that you will take some time to find out where is the median. Right? Even you yourself go and solve it. But if I sort it out, if I sort this particular string in order, in ascending order or descending order, I can just simply find the index, the middle index, that is the median, easily. But if the data is not sorted in order, you will find that you yourself solve this, find the median, you also take time to find. So that is useful. Sometimes we want to find the top 5% in the class. You need to sort. If you don't sort the data, just like this module, we have 800 students. I want to find the top 5%. If I don't sort the data first, I really need to go and remember every single student result and then find out the top 5%. That was very time consuming. So, and in the sorting problem, yeah, people will talk about the stability. Because when you sort one data, okay, then that's not an issue. But a lot of time, we like student the information, we have the age, your age, your class, your result. Maybe you take multiple modules. First module, second module, you got different result. When trying to sort it out, the first factor, maybe your first module, you and we wish that we sort the second column. The first column is still, the orders won't change, which means that there's a stability. Stable sorting algorithm is sort repeated element in the same order that will appear in the input. That's it. Next time you sort it, if like okay, maybe give you an example. Let me see. Maybe can, let's say I got A and B and C. So maybe module 1 and module 2. Then student A maybe receive 80 marks. Then student B receive, let's say, 80 marks also. Student C receive 70. Okay, they already sorted in order. Then the next one, M2, I would like the A, let's say, is 70 marks. Then this one should be this one I wish is 60, 80, maybe 80. Then this one should be 72. No, 70. Okay. If I sort it, first I sort it in this one. Let's say the result in from highest to lowest, so should be ABC, no problem. Then followed by, I sort the second column, M2. Then I wish, of course, C will, if I sort it in that order, then I supposed to move the C to upper column. But A and B still remain unchanged. Then that means that this sorting algorithm is stable. But if A and B, because both are still 70, it doesn't matter you put A first or B first. Because stability means that stable sorting algorithm, they won't change the order. Earlier sorting result already A first, B later. Then after I sorting based on the column M2, then I only move the C to the top. A and B still in order. That's what it means that in the same order that appear in the input. Okay, so that is like sorting algorithm. People were concerned about the stability, especially people working in database. You need to sort the data in multiple column. Then they need to make sure that you won't change the order. Another problem people will talk in computer science, like string. A lot of problem, you have a string, you want to search whether this word is in the string or not. I think yes, here. Yeah, how you search, how you find this particular word in the string. Yeah, that is a string matching problem. And in daily life, you always do, you trying to search the keyword in the lecture notes, in the textbooks, is a text matching. People working in the genome sequence, yeah, bioinformatics, this is the COVID sequence. They're also trying to find, maybe they want to find certain pattern, or they want to compare two variants of the COVID virus sequence, and then yeah, the matching the sequence or alignment, or this, yeah, is a very typical string processing problem, and so on and so forth. Other problem we will not cover in computer science, but actually it's a computer science problem, like computational geometric problem. I think people working in computer graphic, they will use it like they're trying to finding the convex hub. That means it's like given a set of point, you want to find the outer contour to cover all the point. Yeah, that is convex hub problem. And then finding the closer place, then you have a lot of point, then you need to find the closer pair of point in a set of point. Yeah, that is a geometric problem. Yeah, computational geometric problem. Other, you want to find the intersection of two line segment of two circle, or yeah, you want to test whether the point is inside the polygon or outside the polygon, and so on and so forth. All this is a very typical computational geometric problem. It's been used a lot in people working in computer graphic. We need to solve a lot of this. How when they're rendering the 3D object, then they need to know whether the point, especially you consider the light source, you need to consider the shadow, whether they need to then all these things, they need to consider the reflection of the light and so on and so forth. All this, when the light hit the surface and how they reflect through the surface to the camera to form an image, that involve a lot of computational geometric problem. Yeah, so that is another well-known problem in computer science. We need an algorithm. And another problem we will not discuss in this module, but just let you know, is a numerical problem or optimization problem. Numerical problem is very well known in all the engineering. People working in electrical, mechanical, civil, to all the logistic, they all need to use this optimization problem to find the optimum. Like this is a very typical linear programming problem that you have some criteria you want to optimize to minimize this particular condition, and then there are some constraints subject to this. Your 5x plus 3y cannot must be greater or equal to 29, and the minus 2x plus y. X and y, you can think like it can be two factor. Maybe it's the labor cost, maybe it's the material cost. I want to find the minimum cost. Then there are some constraints I need to fulfill. So this is kind of a very typical linear programming problem in optimization. Then they need to solve to find out the minimum. So normally the minimum will appear in one of the convex, one of the vertex, either here or here or here. So yeah, they need to find out a systematic way to solve this kind of a linear programming problem. So that is another typical problem we study in computer science. Okay, then the next thing is like after you know there are all these problems, then the next thing you need to know is how do we solve this problem. So of course you need to store the data first. So not surprising that's why in the first half we cover the different data structure. In fact, earlier in 103 you already learned how to store the data in array, linked list, stack and cube and tree and table and graph in whatever form, which can help you to solve the problem efficiently. Then the solution can be recursive way or non-recursive way. You may need to consider. After that, then you will decide based on the problem, your solution, you will use different kind of strategy. Yeah, there are a lot of ways. Brute force, I think linear search is a kind of a brute force. I just try out exotic search. I just try out all the possible case, all the case. Yeah, test it one by one. And you will learn like divide and conquer. To when you like binary tree, you want to visit all the nodes. You will divide to left subtree, right subtree. Yeah, that is a kind of a divide and conquer. And greedy strategy, you don't know what is the best solution, so you always just choose at that moment the best one. You just straight away go to the best one and look for the next step, but you don't know whether that is the best solution in the end or not. That is a kind of a greedy strategy. Or decrease and conquer. Yeah, binary search is a kind of a decrease and conquer. Then transform and conquer, there are a lot of strategy, not only this. Transform and conquer, you have learned about it. It's like when we cover the AVL tree in binary tree, or when we cover the mathematic expression conversion from infix to prefix. Instead of using this format to solve the problem, I try to transform my input to another format. Then I solve it. I will find that the efficiency improve. Yeah, that is kind of a transform and conquer strategy. So some algorithm later you will learn, like matching problem, we are using the iterative improvement. So there are a lot of strategy to solve the problem. Yeah, you choose different strategy, you will get different kind of efficiency. And which one is better? A lot of time we need to analyze it first. So in short, in this lecture, I just give you an overview about what is the algorithm, and yeah, and all kind of possible the problem in computer science: searching, graph problem, sorting problem, combinatorial problem, computational geometric problem, or those are optimization problem. All these are the very classic problem in computer science. But in this module, we only focus on searching and graph. In the next level, you will learn the sorting and string processing in 2101. And computer graphic courses, they may teach you the computational geometric problem. And when you go to the higher level to specialize in certain area, we will cover those problems. But in this module, we focus on the searching and graph as an example. I would say it's an example to let you know that different strategy can be used to solve a problem and what is their efficiency and how to implement it, how to realize them in a program, as a program to solve the problem. Yeah, so that is what you're going to learn in the next few weeks. Okay, so I think before I end today's lecture, I just give you to roughly know this Wednesday lecture, I will cover about the analysis of algorithm. I will introduce about the time complexity and space complexity, what is the best case, worst case, average, efficiency, and so on and so forth, and why do you need to know order of growth of an algorithm, and how to represent them order of growth. Like just now you have seen, I trying to show you something I write in the O n, O log n, or big O notation. And yeah, how do I represent the time complexity, space complexity by asymptotic notation? I will cover it on Wednesday lecture. Okay? So let me see any question I can answer before I end this live streaming. Can we solve the recursive relation so that the time complexity? Once you are recursive, then unlikely the time complexity can be in constant time. Yeah. What if add memory into matter 1? Yeah, then there's a kind of a later we also cover. You can optimize it. It's like kind of a trade-off that you're trying to remember. You're trying to use more space to store all the results. Then you will find that yes, you can improve the efficiency. But don't forget, because it's a recursive function, then where are you going to store the storage? Likely you will put it in the global as a global variable. That means that particular space is always occupied, because you put it as a global variable. If you don't put it as a global variable, you will have a problem, because recursive function, the next call, yeah, you wouldn't have be able to get the previous local variable. And A star path. Yeah, A star search is another some algorithm for path finding. Yes, but we not cover in this module. I think it's in the artificial intelligence. So we cover it. Okay. This module is all in C programming, even the second half. Any other question? If not, I will end this video, this live streaming. Okay, you expect that the second half, yeah, I will cover only the concept in the lecture. I won't tell you how to implement it. And you need to learn that people give you an algorithm. How do you realize it as a program, into a program? Yeah, so that's why I strongly recommend you to practice those questions in the lab, in the assignment by your own. Yeah, again, I would say I think tutorial and the lab I will release the solution, but I would say not really useful to read the solution. If even the first half you read the solution, you won't learn anything one in the end. You still don't know how to code. The key is we want you know how to code. It's not you know how to read the solution. So make sure you yourself learn how to implement, because from the solution itself, you won't be able to know how people come out that solution. You only know that that is the solution, and in it you don't need to test. You already test it before, so it's definitely work one. Normally, most of the time, unless they make a mistake, no, you don't need to just test whether it work or not work. You should learn is like not read the solution and you yourself trying to implement it, and learn whether you know how to implement it or not. Okay, thank you for your attending. Yeah, okay, goodbye.